All right, this is our first video. We're looking at the first section of Chapter 1 on variables and expressions. We're really going to be concentrating on translating between words and algebra. Math is very much a foreign language. It has its own sentence structure, its own spelling, and we're going to be looking at how those words look with just numbers and symbols, and being able to go back and forth between words and those algebraic symbols. So first, we've got a little bit of a cheat sheet here. We've got all four of our operations, adding, subtracting, multiplication, and division. And we've got some word phrases that all relate to the same expression. And so for addition here, our first row, in the expression, we've got n plus 5. We've got some number n plus 5. In fact, I even used that first word there in our word phrase column, a number plus 5. So some number plus 5 is a way that we could express this expression here in words, n plus 5, some number plus 5. Another way is just to say that we're going to add 5 to a number. Some number, we're going to add 5 to that. And then sum, and this is a word specific to mathematics. It's a specific spelling, S-U-M. And we're going to talk more about those words in a little bit. But sum, so we've got the sum of a number and 5. 5 more than a number. I'm going to put a little star by this one here. I'd like you to do the same. 5 more than a number. What's different about this is that the 5 comes first in the word phrase, yet in the expression, the 5 does not come first. The 5 actually comes last. And so even though it says 5 more than a number, it's expressed as n plus 5. Now that means less in addition. Addition is what's called commutative. But it will show up and be much more relevant for subtraction and division. And the last one, we have a number increased by 5. So those are 5 ways that you can express this expression in a word phrase. All right, moving on to subtraction. So we've got our subtraction sign down there, and we're looking at that second row, a number minus 11. That's definitely the way most of us are used to saying it. We've got some number x minus 11. And so that's the way you're going to hear it a lot, but that is one way of doing it. We are subtracting 11 from a number. Now again, you'll notice that in this sentence structure, the 11 comes first, yet the 11 does not come first in the expression. Subtracting 11 from a number, we're taking some number 12, and we're going to take 11 away from that. We're subtracting 11 from that number. We're going to end up with 1. So that's not 11 minus 12, it's 12 minus 11, which gives us very different results. So you have to be very careful of how the sentence is structured and how that appears as an expression. Difference. Again, we have our very mathematical term here, difference. We've got the difference of a number and 12. Difference in mathematics means subtraction. We have, again, for our fourth one here, I'm going to give it another star. I'd like you to do the same. 11 less than a number. So just as before, the 11 is coming first in the sentence, yet it does not come first in the expression. We want to be very careful with that. That's going to come up a lot, and you're going to see that, and you have to be very careful. Many, many students make mistakes with this simply because they are not looking at their notes, they're not using this cheat sheet, and they're not being careful. 11 less than a number. 11 less than 12. Well, what's $11 less than $12? Well, $11 less than $12, $1. So not 11 minus 12, 12 minus 11. It's the number minus that 11. So you have to be very careful with this particular sentence structure. And lastly, a number decreased by 11. Multiplication and division, you'll notice, are fewer ways of writing it, or fewer ways of expressing it anyways, as a word sentence. But we have, for our multiplication there, we have 3 times a number, 3 multiplied by a number, and then the product. There's our mathematical word there, the product of 3 and a number. So product is multiplication in our mathematical language. You'll notice in the expression column, 3m, there is no multiplication symbol in between those two. When you have a coefficient and a variable right next to each other, a coefficient and a variable right next to each other with nothing in between, it's always going to mean multiplication. So 3m with nothing in between, multiplication. 3m, while a company in Minnesota is also 3 times m for this algebraic expression. Last one, we've got division, a number divided by 7. We've got 7 divided into a number, which I'll talk about in just a minute. And then, of course, the quotient. Quotient is our mathematical word, quotient of a number and 7. I'm going to put a little star by the second division one here. 7 divided into a number. So if you think about that, 7 divided into, say, 21. 7 divided into 21, well, 7 divides 3 times into 21. There's 3 7s in 21. If you have 21 pens, you can divide that into 3 piles of 7. 7 divides into 21 3 times. And so that 7 divides into a number is a peculiar way of saying it. We don't hear it that way very often, but it is a perfectly acceptable way of expressing a division problem. You'll notice in the expression column, we have 2 different ways of showing division with numbers and symbols. We got a fraction or with that division sign. In fact, that division sign, if you look very closely, really does look like a fraction. It's a dot over a dot. In fact, division and fractions are the same thing. A fraction is just division. 1/2 is 1 divided by 2. 5/7 is 5 divided by 7. And so a fraction and division are interchangeable, and so you can write it in either way. All right, let's look at some examples. So, hey, there's Shaggy. So if we want to write this this word phrase, as an algebraic expression, we're looking at this word phrase, 9 less than a number w. I'd like you to pause it. I want you to try this on your own first. So try it on your own. Pause the video, try it, and then I'll come back and I'll keep doing it. All right, I'm assuming that you've paused it, you've tried it. So I'm going to show, we've got this algebraic expression, 9 less than the number w. I want to change that into just symbols and numbers. Okay, so I've got less than. I'm going to look back here. Less than, oh, here I see it in the subtraction area right here, and it actually has a star next to it, so I want to be careful of that. 11 less than a number, well, when the number comes first in that case, 11 less than a number, I want to remember that it translates where the numbers actually last. So 11 less than a number x was x minus 11. Going back here, I've got 9 less than a number w. So I need to remember that 9 less than a number w is actually going to look this, w minus 9, which again has math. It's got its own sentence structure. And that does make some sense if you think about it. 9 less than 20. Well, 9 less than 20 is going to be 11 because it's 9 less. And so 9 less than 20, we'd have to do 20 minus 9 to get that 11. And so it is set up correctly, even though it's a little bit counterintuitive in the fact that we read from left to right. And so we want that 9 to go first in our algebraic expression, but it doesn't. You need to be very careful when that happens. Okay, let's look at a few more here. So I've got two algebraic expressions here, and we're going to try and write those as word phrases. We've got 7, addition symbol, 19, and a b, and then we have some parentheses on the bottom there. I'd like you to try these 2 on your own. Again, pause the video, and then we'll come back and I'll do them with you. So go ahead and pause it. I'm assuming you paused it, so here we go. Write a word phrase for the algebraic expression 7, the addition sign, 19b. So I've got two operations going on here. I have to be very careful of that. If there's more than one operation going on, then we need to set it up in a very specific way. So the 7 and the addition sign, we'll start with that. So we're going to say 7 plus, so I'm just going to use that sign. You certainly could say 7 added 2. You could use any of those 5 words that we have for addition, but I'm going to use the word plus because it's just more natural for me. So 7 plus, I got this 19b. I said before, if you ever have a coefficient and a variable right next to each other, it's always going to mean multiplication. However, I can't just say 7 plus 19b. It doesn't quite work that way, and I can't just say 7 plus 19 times b either. That'll make a little more sense in future examples. What I need to say is 7 plus the product of. And some of you are thinking, well, that seems like a waste. Why would I say that? When you have more than one operation, we need to be very clear as to which one comes first, either through order of operations, PEMDAS, we need to have our multiplication come before addition, or if there are parentheses, parentheses need to come first. And so even if we have, say, the addition inside of parentheses, we want to make sure that it's clear to the reader what operation should happen first. In this case, multiplication would have to happen first. We're following our order of operations. So we're going to say the product of 19 and B. Great. Now that might seem a little bit fuzzy as to why we did it that way. What's really important to remember for now is we need to have that term or that phrase, the product of. If you don't have that phrase in there and there's more than one operation going on, we don't know as readers which operation to do first. We'll see another one here. So we've got, okay, parentheses 2 divided by t parentheses minus 12. If I follow my operations, those parentheses have to happen first. And so I need to say that the 2 divided by t has to happen first. So I'm going to say the not the product of, I apologize, the quotient. The quotient, there's that mathematical term. The quotient of. So we've got the product of in the first one, the quotient of 2 and t. Now I know as a reader that the quotient has to happen first. I have to do 2 divided by t first. Then I've got this minus 12. So I can say the quotient of 2 and t minus 12. And that would be a correct way of writing this. You could certainly say the quotient of 2 and t, 12 less than the quotient of 2 and t, the difference of the quotient, you could make it longer. However, this is probably the most streamlined way that you could write it. If there's more than one operation going on, you need to say the something of. And that either has to be the sum of, the difference of, the product of, or the quotient of. So with only one operation, don't have to worry about it. We know what happens first. There's only a subtraction. With more than one operation, we have to be very, very clear that we need to do the product first. We need to multiply first. So the product of 19 and b plus 7. In the second one, we had parentheses. That has to happen first before the subtraction happens. So we say the quotient of 2 and t minus 12. I got 3 examples here. The first 2, you need to change it into an algebraic expression. So we've got the word phrase. The last one, we've got the word phrase. We need to change it back to an algebraic expression. So going back and forth between those representations. So pause it, try it on your own, and then I'll come back and do some too. All right, I'm going to assume that you paused it. I'm going to assume that you tried it on your own. You went back, you looked at a few of the other examples, and here we go. So we got 6 minus the sum of m and 12. And I notice right away, the sum of, that has to happen first. If it says the sum of, we have to add first. So in parentheses, I'm going to go ahead and put m plus 12. Because I know that sum means addition. So I know that that has to happen first. And I've got 6 minus that. So it's not m plus 12 and then minus 6. We've got 6 minus m plus 12. And I know by looking at the what I've just written, following my order of operations, I'm going to take whatever number m is, add 12 to it, then I'm going to do 6 minus that to get my final answer. Second one, we've got 8 less than the quotient of 9 and r. Again, the quotient of, the something of. So that has to happen first. So in parentheses, I'm going to go ahead and put 9 divided by r. You could certainly write that as a fraction if you preferred, but I'm going to leave it the way it is. 9 divided by r, that's the quotient of 9 and r. 8 less than the quotient of 9 and r. If you put 8 minus, you did it wrong. You weren't careful. You have to be very careful with this. With that sentence structure, I'm going to go back and look at my cheat sheet here. It says 11, here's that circle, circled and starred and all sorts of stuff. 11 less than a number means the number minus 11. 11 less than a number means the number minus 11. And so it's flipped from the way we want to read it. 8 less than the quotient of 9 in R, 9 divided by R minus 8. It's flipped. Be very careful with that term less than. Last one we have a algebraic expression, and we need to get that to look like a sentence in a word phrase. So I've got those parentheses. Now if I forgot about those parentheses, and I followed my order of operations, I'd have to do 6 divided by 4 first. Division would come before addition. However, with those parentheses, I need to do that addition first. So if I just wrote 6 divided by 4 plus h, that would be wrong. I don't want to do 6 divided by 4 first. I need to do the 4 plus h first. So the only way to communicate that is to say the sum of 4 and h. Now I know that the sum has to happen first. The sum of 4 and h, I have to add 4 and h first before I divide. And by saying the sum of, I'm communicating to the reader that that's in parentheses, that has to happen first before the division. Even though division comes before addition in PEMDAS, by adding the sum of, I'm essentially adding parentheses. 6 divided by that, so I'm going to just go ahead and write 6. 6 divided by the sum of 4 and h. And that's how that would look as a word phrase.